last learning target is I can identify different parts of transverse and longitudinal waves. So transverse waves look like this, and I'm just going to draw an even one. I'm kind of picky about waves. I want to make sure they're the same height, the same width apart. They're moving forward, carrying energy. So this is a transverse wave, okay? And if life was perfect, they'd all be exactly the same, right? So this is a transverse wave. I'm going to label it. I think I'm going to label it right here, transverse wave. So there are parts to this transverse wave that scientists need to use when they're talking about waves and how energy gets passed from one point to another. So the top of a transverse wave, this thing right here, is called a crest. So you have a crest here, you have a crest here, you have a crest here. And the bottom of a transverse wave, right here, exactly at the bottom, crest is exactly at the top, right? The bottom is called a trough. Okay? The next thing you need to know is that if you're going to look at how long this wave is, you have to have something to measure. So what's really good to measure is from one crest to the other, okay? So there's similar points on a wave. So this is called wavelength, like how long is the wave. Okay? You could do the same thing on a trough, right? From trough to trough, you could measure wavelength. That would be fine. There are other parts of the wave, but we'll get into those later. So this is a transverse wave. I don't know, I just like to keep it in a box. Kind of fun. P-E-R-S-E, transverse wave. Okay, now we need to talk about the other kind of wave, a sound wave, which we're going to call a compressional or a longitudinal wave, right? So because our learning target says longitudinal wave, we're going to label it that, longitudinal wave. There's a couple ways you can draw longitudinal waves, but I like to just use lines, and you can do the same. So I'm just going to put some lines, and I'm going to try and keep it all the same height. And I'm going to make sure that you can see something called compressions and rarefactions. These are all super straight lines, right? Because I'm super perfect drawing super straight lines. Okay, so this is a longitudinal wave. And so when you can see them pressed together, this part right here is called a compression. That's why it's sometimes called a compressional wave, right? Compression. So compressional wave is also a longitudinal wave, right? So when it's not a compression, when it's farther apart, it's called a rarefaction. Rarefaction. And kind of remember the two, because compression is like pressed together, right? See how those waves are close together? And the rarefaction is when they're like rarely close together, right? So rarely close together, rarefaction. So this is a longitudinal wave and some of its parts. Let's see, some examples of a longitudinal wave would be a sound wave, right? A sound wave is a good example of that. And an example of a transverse wave might be a water wave. All right, more on waves later. Make sure your notebook looks like mine. I am going to use a highlighter just so that I know what they look like. So the longitudinal wave, that's good to label or highlight. The transverse wave, good to highlight. We have our parts, the crest and the trough, and then we have a wavelength here, okay? And then we have a compression and a rarefaction down here. All right, all good parts of a wave. finish your notebook and have a good afternoon or evening or wherever we are in the day.